use the definition to find the derivative of f of x equals 1 over x cubed, then evaluate f prime of negative 1. The first thing to do is write down the definition of the derivative. F prime of x will equal limit as h goes to 0 of f of x plus h minus f of x all over h. The next thing to do is formulate f of x plus h, which means to take f of x, 1 over x cubed, and replace all of the x's with x plus h's in parentheses. That will give us 1 over x plus h cubed minus 1 over x cubed, and then that entire thing over h. Now right now we have the 0 over 0 indeterminate form, and we will continue to have the 0 over 0 indeterminate form until we can factor an h out of the numerator to cancel with that h in the denominator. To get an h to factor out of the numerator, we have to combine those terms in the numerator, which are fractions. So we're going to start with a common denominator. So we have f prime of x equals limit as h goes to 0 of the first fraction has a denominator of x plus h cubed. The second fraction has a denominator of x cubed. The common denominator will be x plus h cubed times x cubed. So I'm going to multiply this first fraction by x cubed over x cubed, a form of 1. And I'm going to multiply the second fraction by x plus h cubed over x plus h cubed, also a form of 1. That entire thing is over h. So we have limit as h goes to 0. Multiplying, the first fraction will become 1 times x cubed in the numerator, which will be x cubed. And then in the denominator, we're not going to FOIL those out. We're just going to keep them factored, but they are multiplying each other. So x cubed times x plus h cubed minus the second fraction will be 1 times x plus h quantity cubed in the numerator. And in the denominator, we will again have x cubed times x plus h cubed. All of this is over h. We can now combine those fractions together over that common denominator. So limit as h goes to 0 of x cubed minus x plus h cubed divided by x cubed times x plus h cubed, and then the entire thing divided by h. Since we have a fraction in the numerator, we're going to take the fraction in the denominator, reciprocate, and multiply it. It's not a fraction just yet, but it can be by putting it over a 1. So I'm going to go and reciprocate and multiply. So I will have x cubed minus x plus h cubed divided by x cubed times x plus h cubed, and all this times 1 over h. And we can multiply those together. Which will retain an h in the denominator. I'll just put it in front, and I have h times x cubed times x plus h cubed. Now our goal is to take that h in the denominator and cancel it with an h that will factor out in the numerator. We don't yet have an h that will factor out in the numerator. What we will need to do is expand that x plus h quantity cubed, combine like terms together, at which point we should have an h in every term. Then we will factor and cancel, and that will finally remove the 0 over 0 indeterminate form. So our next step is to start the process of expanding the x plus h quantity cubed. Now, quantity cubed means x plus h times x plus h times an x plus h. To handle the quantity cubed, we're going to pair off two of them, FOIL those out, and then FOIL it with a third one. So we have limit as h goes to 0 of x cubed minus, pairing off two of them. I will pair off maybe the second two, so I'm going to write x plus h and then times the second two FOILed out. X times x is x squared. And then I will have an x times an h and an h times an x. Those will add together to 2hx. And then I will have an h times an h, which is an h squared. All of this over that same denominator. So we will have limit as h goes to 0 of x cubed minus. And now we're going to FOIL out two terms, x plus h, times the three terms, x squared plus 2hx plus h squared. That's done by taking the first one and multiplying it by each of the three. So I'm going to start with x times an x squared. That will be an x cubed. An x times a 2hx. That'll be a positive 2h x squared. And x times an h squared. That'll be a positive h squared x. And h times an x squared. That'll be a positive hx squared. And h times a 2hx. That'll be a positive 2h squared x. And then an h times an h squared, which will be a positive h cubed. All of that divided by that same denominator, h times x cubed times x plus h cubed. Our next step is distribute the minus sign here into that entire expression. We'll have x cubed minus x cubed minus 2hx squared minus h squared x minus hx squared minus 2h squared x minus h cubed. All of this divided by that same denominator. In the numerator, we can now combine together like terms. Any terms that don't have an h should cancel. Now, I have an x cubed, and if you look, there's a negative x cubed, and those will cancel each other out. I have two hx squared terms. There's one here, and there's one here. A negative 2 and a negative 1 will give us a negative 3 hx squared. I have two h squared x terms here and here. A negative 1 and a negative 2 will give us a negative 3. And then I have one h cubed term. And so I will just bring that along. All the remaining terms should have h's in them, and they do in the numerator, so that we can factor an h out, and that's going to be our next step. I'm going to factor the h out, leaving us with a negative 3x squared minus 3hx minus h squared all over h times an x cubed times an x plus h cubed. The h's can now cancel, so we finally have removed the 0 over 0 indeterminate form. I'm just going to rewrite what we have left, but we will be able to plug a 0 in for the remaining h's. So negative 3x squared minus 3hx minus h squared, and then over x cubed times x plus h cubed. Each of the h's becomes a 0. So that'll be a 0, that'll be a 0, that'll be a 0. And we're left with negative 3x squared over x cubed times another x cubed. In this case, we add those exponents in the denominator when we multiply those two with each other. X cubed times x cubed will give us x to the 3 plus 3, which is x to the 6. And then we can cancel out 2 of the powers from the numerator with 2 of them from the denominator, leaving us with 4. You actually subtract exponents in division, and that'll give us negative 3 divided by x to the 4 to represent the derivative. The last thing to do is evaluate f prime of negative 1. So now we're going to plug a negative 1 in for the x. So we'll have negative 3 divided by negative 1 to the 4th power, which will give us negative 3 over negative 1 times negative 1 is positive 1 times another negative 1 is negative 1 times 1 more negative 1 goes back to positive 1, so that'll be over a positive 1. Anything over 1 is itself, and we end up with negative 3.